Hi everyone, today we will discuss Bresenham's line drawing algorithm. Right. In the previous video we have discussed DDA algorithm. What is DDA algorithm? Digital Differential Analyzer algorithm. It is a line drawing algorithm, and we know the disadvantage in DDA algorithm. Every time we have to round off, right? So this round off function is very expensive. That is the disadvantage with DDA algorithm. And to overcome this disadvantage, we have this Bresenham's line drawing algorithm. And we can see Bresenham's line drawing algorithm now. Here we have to avoid this rounding function, right? We have to avoid this rounding function, so no floating point will be here, and it is more effective than DDA algorithm, and it will be having incremental values, right? To achieve this, that is to overcome the round off function, we have to make a decision, right? We have to make a decision here. So we will be having a decision parameter in Bresenham's line drawing algorithm, right? Suppose I'll write Bresenham's line drawing algorithm. Right. So I'll be avoiding the round off function. So to avoid this round off function, I have to make a decision. This decision is based on the decision parameter. Suppose I have like this, right? Take this as 10, 11, 12. This I'll take some value, right? I'll take as 14, 15. Suppose if this is my first pixel, that is, this is the starting point. You know, to draw a line, I need the starting vertex. Suppose this is my starting vertex, right? What is the coordinate? 10, 14. 10, 14 is the starting coordinate. And next pixel position I have to find out. I have to find out the next pixel position. Next pixel, it can be either, right? You know, every time this x, it will be incrementing by 1. So x value definitely it will be 11. So I have to decide whether the next pixel position is 11, 14 or 11, 15. This is my question. 11, 14 or it should be 11, 15. I have to decide, right? I have to decide what should be the next y value, right? What should be the next y value, right? So to decide this next value of y, I have a decision parameter, right? I have a decision parameter. What is this decision parameter? Decision parameter, I'll use the notation as pk. This pk is directly proportional to the distance of separation between these two pixels. This pk is directly proportional to the difference of distance between these two pixels. I'll put it in a simple way, right? I'll draw this algorithm and this diagram once again, right? So this current value, that is xk, yk, right? And so this is my yk, this is my xk, right? So if this is xk, yk, this is my x coordinate, this is my y coordinate, right? So here next y value, it will be yk plus 1, right? So here next x value, it will be xk plus 1, right? So current pixel position, next pixel position, definitely it will be, x will be incremented by 1. So x position is this one, xk plus 1, but y I don't know. So y I don't know whether I should take yk or yk plus 1. That is my question here now, right? So to decide this, what I'll do is like, I'll draw a reference line, right? Between this yk and yk plus 1, I'll mark a reference value. This reference value is y. This reference value is y, right? So now keeping this reference value, I'll mark this distance as d1 and this distance as d2, right? Based upon this distance, right? What is this? Based upon this distance only, I'll decide what should be the next pixel's y value, right? What should be the next pixel's y value, right? And how I'll you know this slope-intercept formula, right? Y is equal to mx, y is equal to mx plus b, right? In this slope-intercept formula, we know x value, x it travels in unit intervals, so I'll substitute xk plus 1 plus b, right? Now what is decision parameter? Now I'll come to the definition of decision parameter. Decision parameter is the difference of separation. Decision parameter is directly proportional to the distance of separation between two pixels. Difference of distance of separation. So difference of distance of separation between these two pixels. To find out what I have done between these two pixel locations, I have taken a reference value. This reference value I have marked as 1. In this reference value, this distance I am taking as d1 and this distance I am taking as d2, and this decision, my decision parameter, it should be directly proportional to the difference of distance between these two pixels, right? So I have to find out difference of distance. Difference of distance means I have to I have to do subtraction. I have to do d1 minus d2, difference of distance of separation between two pixels. So I have to calculate what is d1. What is d1? Y minus yk. Y minus yk. You know what is y, right? So m xk plus 1 plus b minus yk, right? And what is d2? d2 is equal to, right? d2 is equal to this distance. So yk plus 1 minus y. Yk plus 1 minus y, right? You know what is y. Y value we have here. So yk plus 1 minus m of xk plus 1 minus b, right? And I'll tell the definition of decision parameter once again. Decision parameter, the notation is pk, and pk is directly proportional to the difference of distance of separation between two pixels. Difference of distance of separation between two pixels. So I have to find out the difference of separation. So what is it? I have to find the difference of these distance. So it is d1 minus d2 I have to find out. We know what is d1, we know what is d2. Now I have to find out the difference. So d1 minus d2. So it is m of xk plus 1 plus b minus yk minus of all these values. So minus it becomes plus. Otherwise I'll write yk plus 1 minus m xk plus 1 minus b, right? So it is m of xk plus 1, right? This minus, right? So I have 2. So can I write 2? 2, right? Plus b, when this minus goes inside it becomes plus, so it is 2b minus this minus yk, plus when it goes inside I'll have one more minus yk, so it is 2yk. This minus when it goes inside it becomes 1. So I'll write it 2m xk plus 1 plus 2b minus 2yk minus 1. Right? Now what is pk? pk is directly proportional to the difference of separation between two pixels. Directly proportional. So if I want to make it equal, I have to add a constant. So I'll add pk, right? I'll add a constant, and it is proportional to the difference of distance between two pixels. So difference of distance we have calculated here. I have to write that d1 minus d2. Right? Now delta x, you write this 2m of xk plus 1 plus 2b minus 2yk minus 1. Right? Now you can do one thing. You can multiply this dx inside. You can bring this dx on difference of x inside. Meanwhile, you can substitute the value of m. What is m? M is equal to y2 minus y1 by x2 minus x1. I can write m is equal to difference of y by difference of x. Right? So I am multiplying. At the same time, I am substituting this value to difference of y by difference of x. Right? So xk plus 1 plus 2 delta x b minus 2 delta x yk. Right? Minus delta x. Right? Now what I have to do? Can I cancel these two? And I can write 2 delta y xk plus 1 minus, this is having xk and this is having yk. So next I will write this 2 delta x yk, and the remaining, right, those parameters, those who don't have this x and y, xk yk values, I will put it together. So it will be 2 delta x b minus delta x, right? So you can multiply this inside 2 delta y xk plus 2 delta y minus 2 delta x yk. If you want, you can take this out, delta x, it is nothing but 2b minus 1. Right? Now group it. So it is 2 delta y xk. Next write the yk values, 2 delta x yk. Remaining is 2 delta y plus delta x 2b minus 1. The part that doesn't have xk yk values, I'll write as constant. So it is nothing but pk is equal to, right, so 2 delta y xk, right, minus 2 delta x yk plus this I'll take as c, constant. Right? Now now what I have to do is like, if pk is less than 0, right? If pk is less than 0, where is the diagram? Here. Pk is equal to d1 minus d2, right? d1 minus d2. If pk is less than 0, right? This d1 value is less than d2. d1 value is less than d2, right? d1 value is less than d2 means this, I have to consider this pixel. This d1 is less than d2, so it is closer to this yk value, and the next for the next pixel value, y value, I should consider the previous y value. For y, I should consider the previous y value. That is, if pk is less than 1, it shows d1 is less than d2. That shows, right, every time x it is incremented by 1, y next y value, it should be the previous y value. Right? Suppose if pk is greater than 0, right? Pk is greater than 0 means I am finding the difference of d1 minus d2. d1 minus d2. Right? So if it is greater than 0, right? d1 is greater than d2. That shows x, you know, it gets incremented by 1. What is the next y value? Y also I have to increment by 1. Right? And this is the this is how we find the next coordinates. Next, I have to find the next decision parameter for the very first starting vertex, right? Using this pk value, using this pk, what is pk? It is nothing but my decision parameter. I'll find the decision parameter. I'll find out the coordinate value, x and y coordinate value. After finding the next pixel value, what is the next decision parameter? So what you have to do is like, in this pk equation we got, no, in the place of k, I have to substitute k plus 1. Right? So what is my pk plus 1? Pk plus 1 is equal to, right, I'll show my pk, right? Pk I have here, in the place of k, I have to write k plus 1. So it is 2 delta y x k plus 1 minus 2 delta x y k plus 1 plus c. Right? Plus c. Sorry. I'll adjust. Right? So I have written my pk plus 1. Now this won't be the correct pk plus 1. Every time pk plus 1 value I should find out with respect to the previous pk. So what I'd be doing is like, pk plus 1 I should find with respect to pk. So pk plus 1 minus pk. What I'll get, right? Minus both. Right? So it will be 2, right? You have pk plus 1 here, pk here, minus both. 2 delta y x k plus 1 minus xk. That is, I have taken 2 delta y common and I have written. Then I have taken minus here, which is common, 2 delta x is common, 2 delta x is common, and you write y k plus 1 minus y k. C minus c, it got cancelled. Right? And from this I have to write pk plus 1. So what is my pk plus 1? Pk plus 1 is equal to, move this pk to right hand side, pk, right? pk plus 2 delta y xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. Right? Now pk, you know x I am traveling in unit intervals. Right? So in the place of xk plus 1 I can write xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. Right? So which is equal to pk plus 2 delta y minus 2 delta x yk plus 1 minus yk. Right? This is my pk plus 1. pk plus 1. I'll box it. Right? Now suppose if my starting point is in origin, right? If my starting point is in origin, I have to find the pk value at the starting point. So what I'll be doing is like in this pk, this is my pk equation, right? In the place of xk and yk, right? So it is origin, right? It is origin. So I should substitute k value, it will be 0. x naught, y naught. Since it is origin, this value it should be 0, 0. I have to find out p naught. Right? Initial pk value. Right? Initial pk value. So it will be, so this constant value you have here, consider everything. So 2 delta y x naught for origin, 2 delta x y naught for origin plus 2 my constant delta y plus delta x 2b minus 1. Right? So what is origin means it is 0, 0. So 0 means everything becomes 0. Here also if this becomes 0, everything becomes 0, plus 2 delta y plus delta x 2b minus 1. Now I have to calculate what is this y value. How I will calculate this y value? You know the slope-intercept formula, right? Y is equal to mx plus b. Right? From this find out b. What is b? B is equal to y minus mx. Now at origin, what is x and y value? It is 0, m into 0. So what is my b value? B is nothing but 0. Substitute this 0 here. So what happens here? 2 delta y plus delta x into 2 into 0 minus 1, which is equal to 2 delta y plus delta x minus 1. So it becomes 2 delta y minus delta x. What is it? P naught. Right? So we got 3 equations here, P naught, pk plus 1 and pk. Right? So with these 3 equations we are supposed to do the sum. So I'll consolidate everything. Right? I'll consolidate. To do the sum, first step we need P naught. What is my P naught? P naught is nothing but P naught is equal to what value we have calculated? 2 delta y minus 2 delta y minus delta x. Right? What is my pk? pk plus 1 equation. What is my pk plus 1 equation? Pk plus 1 equation we have here pk plus 2 delta y minus 2 delta x and yk plus 1 minus yk. Right? So it is pk plus 2 delta y minus delta x 2 delta x yk plus 1 minus yk. Okay. now you know if pk is less than 0, right? If pk is less than 0, what about the coordinates? d1 is less than 0, so it should be coordinate value will be xk plus 1 comma yk. If I am consolidating all the equations greater than or equal to 0, it will be xk plus 1 comma yk plus 1. Right? Now, right, to do the sum, right, to do the sum, I have to reduce this equation. I have to reduce this pk plus 1 equation for these two cases. I will do that. Right, derivation is over. Derivation is over. We have found out p0, pk plus 1 and pk values, everything we have found out. Derivation is done. For doing numericals, I will reduce this equation. That's what I am doing now. Right. So what is first case? Pk, I will write case 1. Pk less than 0. So what about the coordinates? Xk plus 1 comma yk. Xk plus 1 comma yk. So what should I do? In this case, what is the next pk? Pk plus 1 value. Pk plus 1 is equal to pk plus 2 delta y. The same equation I am writing. 2 delta x. Right. You know, in the beginning only I told, every time when you see k plus 1, you should understand k plus 1 is just the next value of y. Right. So in this case, what is the next value of y? It is yk. Right. So yk and minus yk. Both got cancelled. And what you will get? Pk plus 2 delta y. Pk plus 1. Right, what is this? If pk is less than 0, this is the coordinate, and for the next pixel, what is the decision parameter? This is the decision parameter. I repeat, if pk is less than 0, this is the coordinate, and what is the decision parameter for the next pixel? This is the decision parameter for next pixel. Next, coming to next case, case 2. pk is greater than or equal to 0, right? Xk plus 1 comma yk plus 1. What I have written here? I have written here. Right? Next pixel will be, both I will be incrementing by 1. So in this case, what is the next decision parameter? Next decision parameter is nothing but this only. In this I have to do the substitution. So it is pk plus 1 is equal to pk plus 2 delta y minus 2 delta x. Right? In the place of this yk plus 1, what is the next value of y? It is yk plus 1. So it is yk plus 1 minus yk. So these two will get cancelled, and what is remaining? pk plus 2 delta y minus 2 delta x. This is the decision parameter for next pixel. In which case? In this case. Right? This is all about your Bresenham's line drawing algorithm, and in the next video we will be seeing numericals for this. Thank you.